Within the past decade, technological advances in horizontal drilling and hydraulic fracturing has enabled the oil and gas industry to extract large quantities of oil and natural gas from shale formation in the United States. Hydraulic fracturing produces fractures in a rock formation that stimulates the flow of oil and natural gas, increasing the volumes that can be recovered. The process uses explosive charges followed by injecting millions of gallons of water, sand, and chemicals miles beneath the surface of the earth into rock formations, releasing oil or gas that might be trapped in the rocks. The injection process includes fracturing fluid, which is 98% water, 1.5% sand, and 5% chemicals. These are forced at extreme pressures into the perforation of the rock, causing cracks. These chemicals can include isopropyl alcohol, methanol, and ethylene glycol. These chemicals are used to reduce friction, counter rust, and to kill microorganisms. This drilling process has potential for groundwater contamination, among other problems. Most of the nations sit atop shale or rock formation that has the potential for producing oil or natural gas from fracking. Fracking has spiked oil or gas drilling in several of these shale formations, posing severe threats. Fracking has polluted both groundwater and surface waterways such as rivers, streams, and lakes, entering our water at several points in the process, including leaks and spills of fracking fluid, the escape of methane and other contaminants from well bores into groundwater, and long-term migration of contaminants underground. In Pennsylvania, state regulators identified 161 instances in which drinking water wells were impacted by drilling operations between 2008 and 2012. In New Mexico, state records show that 743 instances of all types of oil and gas operation polluting groundwater, which serves as the main source of water for 90% of the state. Fracking is very water intensive, as mentioned before, with 8 million gallons of water used per well per frac. While contamination is not just merely caused by fracking alone, a study has found that the proximity of drinking water wells to fracking wells has increased the risk of contamination for residential wells with methane in Pennsylvania alone. The wastewater produced from fracking well contains pollutants from both fracking fluid and from natural sources underground. An estimated 30 to 70% of the fluid used in fracking will resurface and will require treatment. The fracking fluid returns to the surface in large volume, both as flowback immediately after fracking and produced water over a long period of time while the well is producing oil and natural gas. Yet fracking operators have not yet found a safe and substantial way for dealing with this toxic water. To remove these chemicals and contaminants, all methods of wastewater management, including recycling, reusing, and injecting into disposable wells, generally involve some form of treatment. For residuals, all treatment methods produce residuals, whether in the form of liquid, solid, or sludge. In the Marcellus region and elsewhere, solid and sludge are managed through conventional processes such as land application and landfills. For recycling, oil and gas drilling companies have started reusing and recycling the wastewater. Some drillers have used recycling equipment at the well site or trucked to recycling facilities where the wastewater is filtered, evaporated, distilled, and then used at another time for drilling, while other drillers have used the water for a dust suppressant or to melt the ice off of roadways. Highly contaminated backflows, approximately 70% of the total that is injected, can't be treated properly by wastewater plants, so many of the different chemicals that are used in the fracking process could be released into our creeks and streams, poisoning our public waterways, and even after water is treated. Wastewater can be too toxic for conventional treatment plants that is left to evaporate in retaining pods, and these areas may not be used in the future for growing or cultivation. In some western states, fracking waste is spread on the farmlands or used to water cattle. Deep disposal wells are commonly used for disposing of fracking waste. but these wells can fail over time, allowing wastewater and pollutants to mix with groundwater and surface water. While efforts have been made to make hydraulic fracturing safer for the environment and the population, the public should still be aware of the dangers of contaminated water.